everyone. Thank you for joining us today and welcome to ChefConf 2021. My name is Heather Payton. I'm a product marketing lead at Progress. I'm here today to introduce Stephanie Langen, who is a DevOps consultant software engineer with Tapir Technology, where she brings a wealth of knowledge regarding agile development and chef best practices to clients every day. In addition to this amazing session you're going to see and hear today from Stephanie, who's a total overachiever, has also put together a great user guide for implementing Chef with GitLab that will be available to all Chef attendees after the event. Just a couple housekeeping items before I turn things over to Stephanie. We're recording this session. All of the ChefConf sessions will be available on demand post-event. We'll be handling questions for ChefConf through the Chef community Slack. Feel free to interact with me during this event, and we'll address questions at the end. With that then, I'm going to be turning things over to Stephanie. Stephanie, take it away.
Okay, thank you for that introduction. Today we're going to be going over an agile workflow that helps you automatically deliver Chef. This is meant to be agnostic in a lot of ways. This is not platform specific, but Chef specific. So we'll go ahead and jump into it. Thank you for that beautiful introduction. As she said, I am with Tapir Technology. We are a proud partner of Chef, and we mostly are involved with Chef in their federal space. So this workflow that I'm going to be showing you today is something that has worked well with clients before, that is what I consider to be the easiest way to implement Chef, especially when you're starting out. So today I'm just going to be basically going over a brief general talk about workflows. What does that mean? What are the advantages of that? I'm also going to be showing you our starting point, which is just a basic Chef setup. And we're going to go over all of the manual steps needed to go from a change in your code to a change in a live node. And then we're going to go over how all of those manual steps can be automated, saving your developers time and improving your organization's process. I'm going to show you all of those steps in a quick demo, and then we'll talk about how we can make that workflow work with multiple environments. And we're going to examine how to make that same change go from our dev environment to a prod environment. So let's jump in. So what is a workflow? For the purposes of this talk, a workflow is just a set way to develop and deploy your code. A workflow standardizes coding and deployment practices across your team. A good workflow should increase confidence in your code. And this can be done through testing, which basically just ensures that your code does what you think it does. Linting, which just ensures that your code looks the way you think it should look. And through peer review, which ensures that new code is seen and approved by multiple members of the team. So this basically describes a workflow in general, and these can be manual steps that are run by your developers and just the way that coding is done within your organization. So why automate? Why does it matter if these are manual steps or automated steps? Well, automating your team's workflow can have huge benefits for your organization. Automation speeds up the deployment process and can enable your team to be more agile. This creates a dependable way to get new code quickly available in a live environment for real-world testing. And this code can be tested often because your team is getting real live feedback about how it performs in that live environment. This allows your developers to iterate quickly, adjusting early and often by using that critical feedback. This also saves developer time. When developers are able to immediately see how their code will act in a live environment that closely mirrors production with no effort on their part, they're able to spend their own time focusing more so on testing and developing code and basically focusing on those more difficult problems, those exciting challenges that come with coding cookbooks and writing in Chef. Another huge advantage is that this streamlines the team's development process. By including testing into an automated workflow, you automatically are encouraging test-driven development across your team because tests are part of the process. So this leads to a lot less bug-prone code. So with all of that, how does this tie into Chef? So writing code in Chef has a ton of advantages. One being that it's written as code. Chef is policy as code. And since code is malleable, it can adapt as often as our needs do. And if you are a developer, you know that needs often do change on the fly. So it's incredibly helpful to be able to be agile in that way and make changes that's necessary. Another thing is that Chef provides a method for continual enforcement of a run list. This is a huge advantage for automation. When our cookbook is pushed up to the Chef server and added to a node's run list, it will automatically run on the node the next time it checks in, because our nodes that are bootstrapped to the Chef server check in regularly and continually enforce whatever is in their run list. Another huge advantage of Chef is the policy files and policy groups model. Policy groups allow us to define multiple environments, which mean that we can design a workflow that capitalizes on policy groups to manage deployment to multiple environments. Another thing is that policy files provide a single location where a run list is defined for a node. This means that our workflow can focus on updating policy files as the easiest and quickest way to get new code to a live node. So before we go any further, I know I've hit a lot of things so far. I'm just going to go over a couple quick concepts that will be necessary just moving forward. I'm going to refer to a couple things. I want you guys to be able to follow along. So I'm just going to give you a quick heads up. I'm not going to have time to explain all of these concepts today in detail, but I encourage you to do some research on your own if you're unfamiliar with any of these things, because they are a huge part of Chef. So the first one is version control. As we said before, Chef is policy as code. So just like coding in any other scenario, it's important to use version control to manage our code among a team. The one that we're going to be using in this scenario, in this tutorial, is Git. And our Git repository hosting service is going to be GitLab. But I want to be very clear that this workflow is completely agnostic to whatever version control system you choose to use. We're going to be using pull requests, and also known as merge requests. In GitLab, they're called merge requests, GitHub pull requests. But being familiar with what those are and how those work is going to be really important to following along with this tutorial. Another thing is that we're going to be using semantic versioning. And if you're not familiar with that, I highly encourage you to learn up on it, because it can be a huge advantage for keeping track of code changes among your team, where everyone understands what a version change signifies. Another thing that I'm going to be saying often is the term CI/CD. This just means continuous integration and continuous deployment. The CI/CD method that I'm going to be using in this tutorial is GitLab pipelines. Again, this is agnostic to whatever CI/CD service you choose to use. Another thing to be familiar with is that sometimes I'm going to say Chef Infra, or I'm going to say Chef Code. In this tutorial, I'm largely referring to cookbooks. And if you've never written a cookbook before, it's fine. You'll still be able to follow along. Another thing is that I'm going to refer to Chef Inspect or test for our cookbooks. Those are the same thing. We're going to use Chef Inspect to write tests that discern whether or not our cookbooks are doing what we expect them to do. Another piece is the Chef Workstation. It will be helpful if you understand commands like test kitchen, commands like cook style, and other commands that are used for the developer to interact directly with the Chef server. You should be familiar with policy files and policy groups, and you should be familiar with a Chef server. And in this tutorial, I have a Chef Infra and Automate server installed on a single node. That's not necessarily important to how this is set up, but I want to make it clear that when I say Infra and Automate, I'm talking about my Chef server where I'm storing all my code. The last piece is the term node. I'm going to say that a lot, and really I just mean a server or a computer that's managed by Chef that is bootstrapped to the chef server. Okay, let's move on to the fun stuff. Our easy chef setup. This is not the only way to implement Chef, but this is the easiest way I have found to implement it. So I'll walk you through all the pieces. The first piece of this is your developer workstation. This is just a computer with the Chef workstation installed on it that is set up with credentials that allow it to speak to the Chef Infra or Automate server. This is where your developer is going to be doing all the coding. And in my case, my developer workstation is my laptop, and that might be the case for you at home. The next piece of this is some sort of version control system that you're using. I'm using GitLab that uses Git as its version control system. And I have a cookbook repository and a policy file repository in this setup. In my cookbook repository, I'm going to be maintaining a main branch. Some people call that a master branch, and that's okay. The naming doesn't matter all that much. And a feature branch is where new development is going to occur. This is a pretty common pattern, and I'm going to be subscribing to this throughout this tutorial. The policy file repository is going to maintain a development branch and a main branch. And these are each going to correspond to the different environments that we have throughout this tutorial. So my development branch is going to correspond directly to my development environment, and my main branch is going to correspond to my production environment. My Chef server is going to be the server, the place that I store all of my cookbooks with the various versions of them that exist, and that has a dev policy group where policy files are uploaded that are attached to a dev node, and a prod policy group where policy files are uploaded to. My dev node is bootstrapped to the Chef server, and it is attached to the dev policy group. And my prod node, or my production node, is attached to the prod policy group, and that's how it was bootstrapped to the Chef server. And if you haven't bootstrapped a node before, that's okay. But just know that one of the easiest ways to bootstrap your node and define your run list is to use policy files. So with all of these items in place, let's talk about what happens when we make a change to a cookbook. So we're going to talk about how we go from a change in our cookbook code to a change in our dev node. And in this scenario, I'm really just going to be focusing on that change occurring in our dev environment. And we'll come back to the prod environment at the end of the tutorial. So the first step here is going to be basic development. So the developer is going to update the version of the code. So they're going to update the version of the cookbook. They're going to create tests for whatever change they're making. They're going to run those tests using Test Kitchen, and they're going to lint their code using Cookstyle. These should all be basic steps that are standard across your organization, whatever they are for you. These are just whatever steps go into your coder developing the code. And I recommend these steps as best practice when you are making change to any code, right? To have linting, to have tests, and to have some sort of version update or version change. And it just really helps across your organization for everyone to be on the same page, know that your changes aren't breaking anything, and know that your changes aren't breaking any style rules either. The next step is for the developer to push this code onto a feature branch in GitLab. Again, this is version control agnostic, but we're using GitLab in this example during the demo. So once we have our code up on our feature branch, the next step is to create a merge request into the main branch. Remember, our main branch is basically going to define any code that is production ready, that is ready to be up on our Chef server. So in order to make sure that our code is ready to move from our feature branch to our main branch, we're going to request peer approval from coworkers or other people on our team. And in order for them to be confident about the changes in our code, they'll probably run locally Test Kitchen, running of the tests, and Cookstyle, linting, as part of our workflow, or just our process that we do in our organization. Once that change is accepted, it will be merged into the main branch. The next step is manual. We're going through all of these manual steps right now. And the developer is going to have to take that code and they're going to pull that code from the main branch. And then they're going to, in their terminal, use the command knife cookbook upload cookbook name. The knife commands are included with the Chef workstation. And this is the way that we upload cookbooks to the Chef server. So they'll start here, grab the code, use this knife cookbook upload command to push it all the way to the cookbooks where the cookbooks are stored on the Chef server. And this will push up the new updated version of this cookbook to be ready for use for any nodes that want to use it that are connected to the Chef server. But in order for those nodes to actually run the new version of the cookbook, they have to have that information in their run list somehow. So in order to do that, we need to update the policy file that defines their run list. We can do this a couple different ways. And I'm going to take a little pause from all the steps we're going through and take a second to explain a little bit about version pinning and policy files and how this can really help us out here. So in a policy file, you define all of the cookbooks that you want to be run, and you also define what version of that cookbook and where to find it. So in this example, we've set our Chef server as the location to look for our cookbooks, and we are just going to specify what version we want. So in this case, let's say we started out at version 0.10, and the developer that had a change that was accepted into the main branch made a minor change, and this is a semantic versioning. So that would update it to 0.11. If we specified the version of our cookbook in our policy file strictly, then we would not be able to grab that new change at 0.11, no matter what we did to our policy file. We would have to manually change that in our policy file. If we use loose version pinning, we can specify a range of versions that are acceptable for our policy file. And so in this case, using the tilde character, we can specify a range of 0.10 to 0.20, but not including 0.20. So it's 0.10 and then the hard ceiling is 0.20. So when we do that, we can run the Chef install and Chef update commands on a policy file without changing it. And we can update the lock file with the new version if it's a small change, because it's within the acceptable range specified in our policy file. So here, this update will happen either manually, we can change the version of the policy file, or we can just run the Chef install and update commands without changing the policy file with loose version pinning. And those changes need to be made by a developer manually and then pushed up to the feature branch for step 6. So at this point, we have policy file locks that include the new version of our cookbook that we want to test out that live on our feature branch. The next step is to create a merge request and request for peer approval before this gets merged into the development branch. As a reminder, our development branch correlates to our dev policy group, which correlates to our dev environment, our test environment. So when we request to put these changes in the development branch, we're basically saying we want these changes to be tested in our dev environment. So when this is approved, all of the new policy file locks that include the new cookbook version will now live in our development branch. The next step here, and I get that there are a lot of lines on this slide at this point, is that the developer is going to have to manually pull this code all the way up to the developer workstation, and they're going to have to manually run the command chef push dev policy file name. So in this case, they're going to push up whatever policy files have a new cookbook version in them, basically a modified run list, and they're going to push them to the dev policy group. The syntax for this command is chef push, policy group name, and policy file name. That's why I've just stuck dev in here already. So once those new policy file locks, those new run lists that contain the updated version of the cookbook that we want to test, live in the dev policy group, the dev node, the next time it checks in, because it's set to check in continually, will automatically run those new changes. And that is step 9. So Chef's doing a little bit of the lifting here for us, which is very helpful. But basically, these are all the steps that need to happen to get a change in our cookbook to a change in our dev node to get that to actually run. And you've seen that these are a lot of lines. It's kind of complicated. And there are a lot of commands that the developer actually has to run in their own terminal manually. So let's talk about how we can automate that and save ourselves a little bit of time and saves ourselves from a little bit of confusion, right? Because this is a lot to keep track of. So how do we do this same exact thing, making a change, go from our change in our cookbook code to a change in our dev node in just one merge? So let's see. We're going to start with the same 2 steps, right? These are the basic, just developing, testing, updating the version of the cookbook, and pushing it up to the feature branch. But now when we make a merge request, instead of our peers having to run Test Kitchen and CookStyle locally in their own developer workstations to be able to be confident about this code change, our pipeline will do it automatically for us. The CI/CD service in GitLab is called GitLab Pipelines. And so I'm going to be referring to the automated pieces of this as our pipeline. So please bear with me through that. And I've marked every step that the pipeline interacts with or that is done by the pipeline in red so that you know that that is not a manual step. So basically, in step 3, our pipeline is going to run linting, which is CookStyle, and run our Test Kitchen. And when our peers go to review our merge request, they'll see those successful runs and they'll be able to confidently approve our changes. Once those changes are approved and merged into our main branch, our pipeline will automatically run that knife cookbook upload command that had to be run by the developer manually beforehand. And this will just do the exact same thing as before, but quickly and without any human interaction. Here, the human interaction is the approval of the merge request. The next step here is, and there's a lot on this slide. So if we remember our version pinning options that we had from before, I'm going to go ahead and talk about what happens when we use loose version pinning with a minor version change first, and then we'll talk about other options that we have. So let's say we've upgraded from 0.10 to 0.11, meaning a minor change, and this new cookbook version is within a loose range that we've specified, meaning that our policy file is ready to include it if it exists on the Chef server. Well, good for us. Our pipeline has already uploaded that new cookbook version to the Chef server. So what's going to happen is our pipeline is going to say, hey, policy file repository, please update, it's time. So it's going to trigger, which is a keyword in GitLab pipelines. It's going to trigger a pipeline in the policy file repository on the development branch, because we want to test our changes in the development environment before you push them to production. And that is going to automatically run the commands chef install, chef update, and chef push to the dev environment. And if these commands look familiar, it's because they're the exact same commands that were run by the developer manually the last time we went through these steps. And so once that code is pushed up to the dev policy group and with the updated lock files that have that new cookbook version, the dev node will automatically run that code the next time it checks into the Chef server. But let's say something different is the case. Maybe we have strict version pinning for whatever organizational requirement we have, or maybe we need to make some sort of manual change to our policy file that's larger than just pulling in a new version. Well, the developer can also make manual changes and update the policy file, update the run list, and run these chef install and update commands on their own, just like before, push to a feature branch, and create a merge request. Once that merge request goes through peer approval and is merged into the development branch, the pipeline will pick up just as before and will run the dev push or the chef push dev policy file command. And so even if there's a little bit more legwork to do and maybe we're making like a really large change and it doesn't fit into our range that we've specified for our cookbook version, we can just manually change that, and then the pipeline will pick up the rest of the work for us. So let's go ahead and see this in action. In order to simulate a cookbook change, I'm basically going to just show you guys a basic cookbook here called TAR. And this cookbook just installs the program TAR. It's fairly simple. And instead of making any actual changes to the cookbook, I'm just going to update the cookbook version from 011 to 012. This specifies a minor change. And so you guys are aware, the policy file that I'm mostly concerned about is called TAR as well. And it uses loose version pinning to include that cookbook, which means that if I go from 011 to 012 and run chef update on my policy file, it will be able to pull in that new version of the cookbook if it's available on the chef server because it fits within the range I've specified. So with that change made, I'm going to go ahead and add that and commit it. So the feature branch that I'm on is called feature/pipeline. And you've seen that I've made one file change, and I'm going to go ahead and push that up to my feature branch. Now I can go to GitLab and I can look at any code changes and I can create a merge request. So here it says update to version 012, and I'm going to go ahead and not delete my source branch, and I'm going to submit my merge request. And now in a typical workflow, as I mentioned before, peer approval is a crucial part of ensuring that your whole team is on board with changes in code. However, I'm by myself right now, so we're just gonna go ahead and we're gonna say that this is a good change, and we're going to merge this code when the pipeline succeeds. Now, what does that mean? Is the pipeline already running? Yes. So I've set up my pipelines in GitLab to run as soon as a merge request is created. So let's go ahead and look at that pipeline run and see what's going on. As I said before, in order to ensure that your code is that people can accept your merge request confidently, we're going to run Test Kitchen and Cookstyle. So I'll show you that my pipeline does just that. It runs two jobs. One is called Cookstyle and the other is called Test Kitchen. It's just going to perform those actions right now because we're on a feature branch still at this point. So we can look at our Cookstyle job and see that it was successful. So it says it inspected 6 files and found no offenses. That's exactly what we want to see. In the Test Kitchen job, we'll take a little bit longer to run because we are spinning up an EC2 instance in AWS. And if you haven't tried out the AWS option for Test Kitchen, I highly recommend trying it out, especially if you already have AWS credentials on hand and you, it's a really easy thing to set up on your own. And so we can see that basically it expected tar to be installed, and it had 1 successful test, 0 failures, and 0 skipped. And this is exactly what we want to see. And now it's going to terminate the instance for us. But overall, this job succeeded, which means our code change was good. And earlier, when I set my merge request to be accepted or merge automatically when my pipeline succeeded, we can see that that pipeline was successful. This one on my feature branch. So now when it's merged into master, and I do know that in my slides, I use the word main branch, and in this tutorial, I'm using the word master. Naming is, not going to trip up my pipeline. It's set on the master branch here, but you can use whatever naming convention is standard for your organization. So here we see that we're running Cookstyle and Test Kitchen again. That might seem a little bit overkill, and I recognize that, but linting and testing is a really good way to add confidence to every single change your code makes. There could be an instance where merging code into your main branch or your master branch actually does break something due to like some sort of conflict you weren't expecting, get to override something. So it is important to make sure that you're running those tests every single time. And this just ensures that everyone on your team can look back and see that these tests pass and know that these changes really do what you think they do. So we'll allow that to run, and you've already seen those successful runs before. So I'll just take a second here to allow the job to finish up. And I'll point out real quick this cleanup job. So whenever you run Test Kitchen, there's like a chance that if it's not successful, that EC2 instance or that VM that you've spun up could just end up floating around if you don't run the kitchen destroy command. Because on a failure to run kitchen test, it won't always destroy because it'll allow you the option to like continue developing your code and try to make changes and then run your converge again. So I have a cleanup job that's only commanded in it is just to run the kitchen destroy command. And that job will only run if the Test Kitchen job is unsuccessful. So now we can see that the Test Kitchen job passed and we don't need to run the cleanup job. So now we're going to run the deploy prod job. So this deploy prod job, as one of the steps that we talked about before, is really just gonna run the knife cookbook upload command. And more information about how to write these pipelines for GitLab specifically is going to be available in the handout that was mentioned before. So going back to look at that last job that was part of that pipeline, it says trigger policy file update. And this actually triggers the pipeline in the policy files repo to run on the development branch. So we can look and see exactly what's happening in this job. So here we're going to run for every file in our public working directory. If it's a policy file, meaning it ends in .rb, then run chef install on that file. This is going to cache all of the cookbook versions that are included in its run list. Then we're going to run chef update on all of those files, meaning if there are any new cookbook versions available on the chef server, grab them and include them in the policy file lock. And then we're going to run chef push dev on that policy file. meaning now upload that policy file to the dev group. And in my pipeline, I'm actually committing those changes so that those are persistent on my development branch. So now that that job has succeeded, I know that this new version 0.12 is actually up on the Chef server and is now included in my policy tar. So we can see here, we can confirm that uploaded policy tar to policy group dev, and we're using tar cookbook 0.12. So let's check that out on Chef Automate. So it looks like we have our dev node here. And if we look at the run list, so we'll click on this node. It looks like it checked in 2 minutes ago. And we can see now, after refreshing, that we actually are running this new cookbook version 0.12 of tar instead of 0.11. So with that, let's talk about how we get to changes in our production node. So how do we get that change that we just tested in dev to prod once we've ensured that we like the way that it runs on our prod node? So these steps should be pretty familiar at this point. We're going to create a merge request from the development branch of our policy file repository into our main branch. And once that's approved, our pipeline is going to run chef install, cache all of those versions of the cookbooks. We actually don't need to run chef update here because we don't need to grab any new versions. We want to take exactly what we tested in the dev environment that's tried and true and put that into our prod environment. So we're going to run chef install in the pipeline, and our pipeline is going to run chef push to the prod policy group for that policy file. And then automatically, when our prod node next checks in, it's going to run those new cookbook changes that have already been tested on dev. And that's it. Pretty easy, only 3 steps. So with that, thank you for listening. Thanks for being part of this. And we'll hit some questions.
Great. Awesome job, Stephanie. That was amazing to see at the end all that work funnel down into just 3 steps. So great job. Yeah, we've got some questions coming in. If you have a question, just ping me on Slack and I'll try to pick it up. Our first question, I noticed you ran Cook Style and Test Kitchen in the feature branch MR and again in the main baseline pipeline job. Why would you run the same jobs twice?
Yeah, so that's actually, again, like I said earlier, it's like very overkill to run that over and over in every branch. But running linting and testing really adds confidence and is a way that you can standardize, does this code do what I think it does? And does this code look the way I think it does across your organization? So I've included that as a step at every single branch in my cookbook repository. And I highly recommend that you do that because it doesn't take that much longer to run, and it does add a lot of confidence in your code.
Great. Here's another question. You used GitLab in this example. Would the process be similar with Jenkins?
Yeah, so this workflow is really meant to be agnostic to whatever service you're using. So instead of writing a GitLab pipeline, you could actually write a process to work in Jenkins. And so whatever syntax that you might need to write those files will be different, but the actual commands that you're running, like knife cookbook upload and our chef push commands, those are all going to be the same across the board.
Awesome, cool. Okay, next question. If you have multiple policy files in the same repository, is it possible to use this workflow to update only a single policy file instead of all of them?
Yeah, so that's something that version pinning can really take care of for you. If you don't want certain policy files to be updating to include newer versions of cookbooks, you can just write those policy files using more strict version pinning so that you know that policy files that you do want to be updated can be written with looser version pinning. So you can just run those chef update commands and only update the policy files that you want.
Okay, next question. How does the automatic workflow to deliver policy changes work? If I need to introduce a specific policy file change, like an update run list or override a specific attribute?
Yes, so this workflow really does focus on cookbook changes and getting those onto your notes. So if you need to make any policy file changes, you can just make those changes and then create a merge request or a pull request into the development branch, and your pipeline will push all of those changes that you've manually made up to the dev node to be ready for testing.
Great. So last question. This is one. I know you're fairly new to working with Chef. How hard was it to kind of get going with Chef and learn Chef?
So it was kind of a journey. I don't know if anybody is like starting off and feels a little bit intimidated. It can be a lot when you're first starting. You're like, whoa, this is like the syntax and what's InSpec and what's infra. So I really relied on that Learn Chef website, and I just went through those tutorials. And within a week or two, I was writing my own cookbooks. I was writing my own InSpec tests. I was using Test Kitchen. And so you can really get started quickly, but there was a little bit of apprehension at the beginning for sure. And really, I think that you don't even have to be a coder to write cookbook code. This is really something that uses the Ruby language that really makes things human readable. So when you're writing cookbook code, it should be legible for someone who's not technical. So that really is something helpful about Chef.
Awesome. Great. Well, I think we're at the time for the session. I don't see any more questions. With that, I just want to thank you for your time. Thank everyone for joining us, and I hope everyone has an awesome time at ChefConf. Thank you.
Thanks.